So in sensor evaluation, we do evoke, measure, analyze, and interpret. And one of the last things we do during the analysis phase is the significance testing. So you have your numerical data, you have your descriptive statistics, ginawan mo na siya ng, in-arrange mo na siya ganyan, but you want to know whether the results are statistically significant or not. And this is what is called significance testing. So pag sinabi nating significance testing, that is a statistical way of verifying if you could reject a null hypothesis or you wish to qualify for statistical significance. So remember, may kita nyo minsan sa mga ads, di ba, mga 8 out of 10 moms like this product better than the leading brand, blah, blah, blah. So ideally, statistically significant yun. You can't just interview like 10 moms and because 8 of them said yes, then that's it. Kasi as we saw earlier sa mga distribution, that could well have been due to chance and not representative of the population, so to speak, no? So to have a certain level of confidence that your results are not due to chance, then you want to do significance testing. But I do wish to take note, however, that not everything that is statistically significant has the same level of significance in real life situations. For example, parang if something is significantly sweeter than another product based on testing for human responses, though that may be true, that does not necessarily mean, halimbawa, na mas magugustuhan ng mga tao yung sweeter product na yun or something. Okay, so depende rin kung ano yung tinetest mo. And that's why we also look at qualitative comments of individuals on top of running the numbers. Alright, so one thing na medyo hindi nag-agree mga statistician is yung stating ng null hypothesis, no? So generally, there's a school of thought na dapat pag null hypothesis, you are pitting out only yung operation na equal. So for example, if you're testing the, let's say, mean sweetness rating for two samples A and B, the mean sweetness for sample A is equal to that of sample B. In short, parang hindi perceptible yung difference ng tamis nila kahit na magkaiba sila ng amount ng asukal in reality, no? The other school of thought is saying that basta may equal sign, so you can have a null hypothesis that states greater than or equal to or less than or equal to. So generally, you could choose either, no? Pero I think mas safe yung parating equal in terms of mas less yung mga away sa'yo ng mga tao. Okay? But when we have the alternative hypothesis, this is the thing we want to test. Halimbawa, gusto kong i-prove na yung alternative hypothesis ko ay totoo. Na sadyang kayang malaman ng mga tao na may difference in sweetness itong si sample A ko versus si sample B. Okay, so therefore you now have either a not equal sign, okay, not equal, or a greater than or less than sign. So kapag usually greater than sign yung ginagamit mo or less than, ang tinatawag natin dito is a one-tailed test. Okay, one-tailed. Ibig sabihin may idea ka kung saang part ng curve, whether to the left or the right of the mean, yung ine-expect mo na value na lalabas. For example, if it says here that the free fatty acid value of the virgin coconut oil you assume is has a mean greater than 0.5%, then the null hypothesis would be that the mean is equal to 0.5. The alternative is that the mean is greater than 0.5 kasi wala ka namang pakialam kung ang result is less than 0.5. It would still not support your alternative hypothesis. Okay. On the other hand, if for example you want to say na you think that the panelists will give a score of less than 6 dun sa hedonic rating ng iyong fruit beverage, then the null hypothesis would be that the mean is equal to 6 and the alternative is that it is less than 6. Typically, yung iba ginagawa sa ibang school of thought, ito gagawin nilang greater than or equal to. Tapos ito naman gagawin nilang less than or equal to. Pero, yun nga, not everybody agrees on that, but it has little practical significance in terms of interpreting results, no? On the other hand, if you have a two-tailed test, usually this means that you are unsure of whether or not the the alternative hypothesis will be on either direction of the value o hindi mo alam kung ano yung ine-expect mo, no? So, this is true usually when you're testing for something na hindi mo alam yung magiging effect, no? For example, if you want to check the blood glucose level for obese patients, and you think that the mean value for that is 100, the alternative hypothesis would be not equal to 100, which means pwedeng less than 100 siya, statistically less yung mean, or statistically greater than 100. So it could go in either direction, and you don't know. Or for example, the average pH for a fruit beverage is 3.5, so you state the null hypothesis as the mu equals 3.5, or the mean pH of the fruit beverage is 3.5, and the alternative is not equal to 3.5, meaning to say you're willing to accept an alternative hypothesis na either greater siya or less than that value. Okay, so before we continue, yung one-tailed and two-tailed testing, rule of thumb is that you can consider it as one-tailed kapag may idea ka dun sa direction niya. Like for example, kung nagdagdag ka ng asukal sa formulation mo versus the original formulation kung saan nakabase yung null hypothesis, then you're testing for sugar, then you have a one-tailed um, alternative hypothesis stating that it's greater than the mean. On the other hand, if you want to test, let's say, the difference between the acceptability parameters of the brand you're making versus the nagtatawag dito, yung kalaban mo, then hindi mo alam kung in what direction yon, kung magiging mas greater ba siya or less than. So, you may use a two-tailed test. Unless you only care for your brand being better than the other, in which case you would opt for a one-tailed test. Alright, so just some terms now. The test statistic is the quantity na pinagbabasihan natin ng null and alternative hypothesis. So ito yung equal to blank, ano yon. And then the critical region or rejection region are the values for the test statistic which we reject the null in favor of the alternative. So that depends kung ang nilagay mo ay not equal or greater than or less than. So obviously kung not equal, then lahat ng hindi yung value yon. Okay, and then the acceptance region is just the values of the test statistic which we accept as the null hypothesis. So if you're from the school of thought na ang null hypothesis can be yung greater than equal to or less than equal to, then syempre pwedeng lumaki yung acceptance region mo, no? And the critical value is simply the last number observed. Parang ito yung pinaka-boundary mo from the acceptance region and the critical region. Although in reality, kahit hindi nyo matandaan pa basta naiintindihan nyo yung concepts, okay na kayo doon. So, statistics is based in probability, and therefore meron pa ring small chance na magkamali yung interpretation mo, no? Type 1 error is when the null hypothesis is true, but you reject it. Okay. And this is often called a false positive, like here. Okay. And then type 2 error is when you accept a null hypothesis when it is false, or what we call a false negative. Okay. So either way, it's the risk that we're taking when we're dealing with statistical tests, no, na merong small margin of error na maaring mali pala yung iyong conclusion, and that is why we usually experiments are usually repeated like by other institutions or in other countries to see if they would arrive at the same result. And the more incongruence yung results mo sa results na ginagawa ng iba on the same experiment, then the more na nabavalidate na tama yung ginawa mo. So the consequences of committing a type 1 or type 2 error, of course, is dependent on ano ba yung hypothesis mo, di ba? So, syempre, kapag yung decision mo on hypothesis testing would spur a decision, let's say, in your company to whether or not change this product or so on, or sell this product, then committing either error would result in either being conservative about a lost opportunity, or on the other hand, pushing forward with something na biglang nag-flop naman yung product mo. Anyway, there's the thing we call the power of the test, and it is considered as the probability of rejecting the null hypothesis. It's usually denoted by 1 minus beta. So usually when you increase the probability of a type 1 error, you would decrease the probability of a type 2 error, or the other way around. However, the best way to reduce both types of error, kasi hindi na tayo pupunta dun sa statistics ng pag-compute ng power, no? Pero generally, we want to increase our sample size relative to the size of the population and decrease variability in any way possible. So yung evoke natin, dapat lahat ng pwedeng i-control ay makokontrol natin. So students usually have a hard time stating their hypothesis. No? Yung skill talaga dito is kailangan as an equation, kaya mo siyang i-state. And then kapag tinranslate mo yung equation into words, ay naintindihan mo rin kung ano yung ibig sabihin. But you want to start with the objective of the test. Ano ba yung sensory evaluation na gagawin mo? Para saan? Nag-reformulate ka ba? Magpapalit ka ng ingredient? Gusto mo lang malaman how you fare compared to the competition's product and so on. So you write that down, and then based on that, you state your null and alternative hypothesis. Usually, it's the alternative that you want to prove. No? Kung halimbawa, yan ay competition na gusto mong masabi na my product is more acceptable than theirs, consumers will like my product more than theirs. So your null hypothesis would be that the mean liking parameter is equal for both um, products A and product B. Kung ano man yung parameter na yun na gusto mong sakatin sa sensory test, yun yung ilalagay mo doon. And then you look at the significance level and assumptions. So usually, di ba, yung nakikita nyo significant at 95%, 99% confidence level. This simply states no that um, when you say 95% confidence or significance level, then there is only a 5% chance that um, that conclusion we will arrive at is not due to chance. Okay, and then you look at the which sensory test you could use and which data analysis tools you could use. Okay, and also which descriptive statistics you could use to um, test your product, or make conclusions about your product afterwards, after collecting the data. Okay, then you look at the statistic, yung test statistic mo, kung kumusta siya, ano yung mean niya, ano yung standard deviation, i-run mo siya dun sa stat test, tapos based on the results, you simply decide to accept or reject the null hypothesis, and then based on that, you state your conclusion. Sounds easy, no? Pero yung isang buong experiment nyo na magpapatikim kayo ng 50 tao ng, let's say, hotdog or something, dadaanan nyo lahat yan, including how to minimize variability, only to arrive at a simple conclusion. Okay, we're following the school of thought that the null hypothesis would be always using the equality sign, thereby specifying a single value for the null hypothesis. Okay, and you choose whether it's one-tailed or two-tailed. So kapag one-tailed siya, let's say to the left of the mean parameter you chose, then you are no longer concerned with any value obtained that is leaning towards the right. Although normally, technically pag tiningnan mo, meron kang option na neither rejected yung null nor accepted yung alternative. Pero in general, kinoconsider na lang as accept at hindi ni-reject yung null pag ganun yung case, no? So if you've been looking at research journals, usually kapag may mga scientific quantification yan, parati silang gumagawa ng statistical test tapos may dinidisplay silang p-value, which is the lowest level of significance at which the observed value of the statistic could be considered significant. But generally, it's a number, and you want it to be as low as possible, or at least less than, um, if your 95% confidence level, less than 0.05, or less than 0.01 if at 99% confidence level. So simply put, if you run any statistical test that displays a p-value, then that p-value should be less than your confidence level, less than these values, for you to say that it's statistically significant and unlikely to be due to chance. Of course, the higher the confidence level, that means the more confident you can be, or the lower the p-value, the more confident you can be na hindi talaga due to chance yung nangyari at statistically significant talaga siya. Okay? And usually the null hypothesis is rejected when the p-value is less than or equal to alpha, or the test statistic falls in the rejection region. So yun nga, if your alpha is 0.05, your p-value needs to be less than or equal to 0.05 for you to accept the alternative hypothesis. Okay, so there are many types of significance testing, no? And this would normally depend on the type of level of data measurement, whether it's nominal, ordinal, interval, or ratio. No, kasi meron dyan halimbawa, pinapili mo lang yung tao between brand A and brand B, ano yung mas gusto mo? So, essentially count data yon, no, that could be treated either nominally or ordinally. Bibilangin mo lang ilan yung pumili ng product A, ilan pumili ng product B, and then you compare that statistically dapat against a 50-50 chance na piliin either, di ba? And so on. No? However, if it's something like pwede ring ranking, na rank the following according to your preference, or rate the sweetness intensity from a scale of 0 to 100. So, iba-iba yung statistical test that would apply to those, if you can remember yung discussion on parametric and non-parametric stat natin. Okay, and we also want to know if the data is continuous or discrete, are there integers, and so on. Data normality, again, if it's parametric or non-parametric. So there are tests for this, but the rule of thumb again is typically when you have nominal or ordinal data, it's automatic na non-parametric siya. If it's interval, depende kung totoo yung pagka-interval niya o hindi. Kasi if you say you made a scale of sweetness from 0 to 100, but that is not psychologically tested, kung yung taong sumagot ng 10 versus 20 ay talagang nakaperceive ng difference of 10 in the sweetness, then you cannot assume that it's parametric. And lastly, you want to look at the variance between the groups. Okay. Okay, so the next is you want to look at the circumstances of the experiment. Number of groups. Usually, if there are only two groups, no, ginagamit mo dyan yung mga t-test and other similar significance testing. And then, if you have three or more, ang madalas na ginagamit is the analysis of variance, no? Because plus post hoc tests kasi, excuse me, kapag halimbawa meron kang tatlong sample, pwedeng gusto mong malaman sino yung may difference. Is A different from B but B not different from C? Parang ganun. Or is A different from C? And so on. So, habang dumadami yun, dumadami din yung parang pairwise comparisons mo, no? And we want to have a test that can do simultaneous pairwise comparisons to lower the error propagation. On the other hand, we have what we call independent versus dependent groups. So, if halimbawa you're just testing two groups like brand A versus brand B, or males versus females, those are independent groups. But if, however, say in this case, you have one assessor rating 3 samples, so all the assessors rate all of the samples. So yung across each assessor, yung rating niya sa product A, B, and C, you take that into consideration, no? Versus having products A and B tapos magkakaiba yung nag-assess sa kanila. Alright, so those are related groups. Isa ring example ng related groups is kung halimbawa tinetest um, yung ability mo to discern taste and flavors, tapos ang meron kang dalawang setup din. Okay, parang before and after something. Alright, so related din yan. Basta kapag related, ang kailangan mo lang isipin is that um, yung may response for each variable or category, yung same na assessor or subject mo. So remember, kaya tayo nagsasampling is that we want to test only a fraction of the population and hopefully derive a conclusion that represents the response of the population, even if you only tested a small portion, representative portion of it. Okay, so usually kung meron tayong doubt regarding the scale, mas okay na gumamit ng non-parametric statistics, no? Kasi ang ibig sabihin talaga pag parametric, you have a lot of assumptions in place regarding the distribution of the data and whatnot. Although, so yun actually yung isang error natin madalas na nag-a-assume tayo na pwede mong gamitan ng parametric test yung isang bagay. There are a lot of resources on this that you can view haba na yung discussion natin, but we'll try to discuss this further as we go about the individual tests na gagawin natin that should require either. Generally, as you have a bigger sample size relative to the population, mas na-assume natin na pwede siya sa parametric testing kasi nga mas nag-approach sa normal distribution yung isang set na sample or a group of panelists in this case kapag mas marami sila. Alright? However, of course, there are tests to check if your data is parametric or not. But generally, basta malaki-laki yung sample size mo, pwede mo nang i-assume na parametric siya. So this is a quick table that we could use, no? If you're looking at mostly nominal or even at times ordinal data, you can use these non-parametric tests. So that depends on what number of groups you have. Like isang pares lang ba ng sample yan or marami, or whether or not independent or related yung groups mo. Okay, so here are some applications and these tests we'll try to discuss them, but generally if you have statistical software, usually may mga pang-automatic na yan na basta sinelect mo yung data at naka-ayos yung data mo, they could run the test for you without you having to do the individual equations. No, kasi application lang naman ang habol natin. Right, so as I said before, if you have ordinal data, there are also tests you could use, but generally non-parametric pa rin. So you have the Friedman-Wilcoxon and so on signed rank test. We'll discuss this in detail, but it's good if you kahit meron kayong nito, no, parang kopyahin niyo tong mga to na listahan para meron kayong quick reference na hindi na kailangan balikan yung slides or yung video, no. Kasi very useful to. If you know what data type you're using and what application number of groups and group types you're dealing with, then you can choose the proper test. So take note na there are some cases wherein more than one test is possible. For example, Wilcoxon and the sign test can both be used for the exact same context. Okay. Alright, so most of the food tech tests that we do are actually parametric, no? Especially outside sensory evaluation if you're doing pH testing or food analysis kayo ng something na may quantifiable value. So you could actually use these tests, no? Generally, it's a puro t-test and ANOVA lang, no? yung mga ginagamit natin or the test for repeated measures. Now, these are what we call post hoc tests, no, multiple comparison tests. So, for example, analysis of variance will tell you, halimbawa meron kang samples A, B, and C, no? Tatlong sample. Tapos sabi ng ANOVA, uy, positive not equal yung means niya. Mean A not equal to mean B not equal to mean C, or at least one pair out of the three means are not equal. So, hindi mo ngayon alam kung ang not equal ba ay si A versus B, B versus B, B versus C, or A versus C. So, doon papasok itong mga multiple comparison tests or what we call post hoc test na after mong gumamit ng, let's say, analysis of variance, ito naman yung ina-apply mo para malaman kung alin doon sa mga pares ang significantly different. Okay? And each of these have a level of power. So, yun nga, depende kung na pwedeng conservative ka or very liberal. Ibig sabihin, nag-risk ka rin ng mga type 1 and type 2 errors mo, depende kung alin yung pinili mo. We will be digging deeper into relationship analysis at another time, although not the romantic one, no? But let's first look at the three different levels of relationship analysis for statistically treatable data. First is you have the association, wherein you have nominal or categorical or countable data. So you can use cross tabulations for this one. And it gives you a measure of the strength of association. Na usually yung mga demographics, halimbawa, i-correlate mo yung marital status, for example, sa amount of disposable income para magamit mo sa pag-analyze ng mga buyers ng iyong product, parang ganon, no? Or age, for example, age bracket, no? So, correlation, on the other hand, can deal with either ordinal interval or ratio data. So, and you can use statistical expressions like the Spearman's or Pearson's R statistic. So, ito naman ay it just gives you, pag tinabulate niya yung data, ano ba yung strength of relationship nito from -1 to +1 usually, or 0. May correlation ba, strong or weak, positive or negative. Regression, on the other hand, is the highest level and reserved for ordinal interval and ratio data. Basically, you crunch the numbers until you can make a predictive equation regardless kung how many variables yan para malaman niya yung relationship ng variables mo, whether, example, for sensory evaluation, na may ano yung effect, for example, ng levels ng um, chemical compounds doon sa perceived taste ng isang product. Parang ganon. Okay, but we'll discuss this at a later date.